Hi, this is Roger from Kanka Labs, and as you can see today it's about a comparison of 4 available component or semiconductor testers or analyzers, however they are called. Each one has its own designation. First of all, let's talk about the price range. This one here, which sells usually under the name Fish 808040, is around 30, between 30 and 40 bucks, available at eBay or Alibaba.com or AliExpress. These two models here from Peak Atlas, they are from made in Great Britain, and the cheaper one sells for around 60 euros. The more advanced one with a USB connection and with the capability to draw, to serve as a curve tracer in connection with your PC is the most expensive one. It's around 100 to 110 euros. And this one here, the AS4002 semiconductor analyzer, sells as a kit for around also 60 euros. There is also a copy of this available if you search for AS4002 at AliExpress. You perhaps will find a copy of it selling in the range between 30 and 40 euros or dollars, but it neither has a case nor can I definitely say if it has the most recent firmware. So this is the original from the original developer, and as far as I know, although I own this already for nearly 10 years, I think it's the latest software here inside. So before we make a detailed comparison with real test objects, let's talk a little bit about the outside of them, how they work, what they basically can do and what they cannot do. This one here, the Fish 808040, which we also have available at our shop. As you can see, it uses a 9-volt standard battery. It has auto power off, so this off button is superfluous. It has a graphical LCD, as we will later see. Thereby it can also display the circuit diagram of, or the symbol of the component that it has detected. And it has a zero force test adapter, as well as some pads here, which are relatively useful when testing SMD components. But what's a little bit annoying is perhaps now on your screen you can read here the numbering of the test pins: 1, 2, 3, 3, 1, 2, 3. So there are multiple ways how you can insert your test object, your device under test. But if you sit in front of it like I know, I can't read the numbering, and that way I always have to get my head directly over the test fixture here. And that's a little bit annoying. And what's also annoying, there are no test clips available. Of course, you can do your own and solder them to the test pads here. But there are many times when you neither can put your device under test into this test zero force insertion test fixture, nor can you put it on the test pads, and you need some connections with test clips. So at least you can do it on your own to later add homemade test clip adapters, but it's a little bit annoying. and there is no case available, but I give you the link down below in the comments. There is a 3D model at Thingiverse, so you can, with a 3D printer, you can print a case of your own. Now, next is the AS4002. As far as I know, this was originally a project published by Elector magazine around 10 years ago. And the developer probably decided to build it commercially. It's, as I already mentioned, it's sold as a kit. I'm not sure if it's really open source. If you search for it on the internet, then you will find some hex files with the firmware. The circuit diagram, that is open source, but I don't know if you get the latest firmware, which, if we switch it on, you can see it here. It's version 4.03. So if you find version 4.03, you even can build one of your own if you have the if you have a PIC programmer available, because as a microcontroller, as far as I remember, it's a PIC. While this one here, that's quite interesting. It has an 80 mega 32.8p inside, and you will know this is the controller that is also used in the Arduino. And on the back side, you even can see here is the standard 10-pin header for the ISP programming, so you can flash the firmware if there are any advanced firmwares or later firmwares with improvements. You can flash the firmware on your own. You even could probably build one on the Arduino base. That's also something you should know. The LCD relatively easily falls out of its casing, so let's put it back again. It's as we later will see, it's for the price, it's really the best bang for buck you can get. And as far as I know, the original was developed, as I already told you, by a German ham radio amateur. So it is, as far as I know, completely open source. And that's probably why the Chinese clones, as this one probably is, which sells under Fish 808040, why there is no problem with the original developer. So with the let's go back to the AS4002. As you can see, you have a small header with the 3 test pins, and also a little colored code, black, blue and red. And here you have a 3.5 millimeter standard audio jack, and this adapter is available as addendum to the kit. And there is a second addendum you can plug in. That's for testing optocouplers. I don't know if we have time to show the testing of optocouplers, but anyway, it can do this. And when I bought the kit, I also bought the commercially available adapter. It's not very cheap, you won't believe it. It's, I think, 14 euros only for this little adapter cable. But you should have one, because that's one of the things that really makes it very useful to have both the connection here, where you can plug in, let's take an example, here a power MOSFET very quickly, and for components which either don't fit or which are into this pin header, the parallel to the pin header connected test clips. That's really the best solution from all 4 devices that you have both available. This one is, I would say, the second best, because at least you can solder mini test clips to the pads as an addition. And the 2 Atlas types, they come with only these standard test clips. Nice feature of them is that not only the wiring are colored cables, but also the test clips. So here you sometimes, if you're colorblind, you will get in trouble with this. But they only have the test clips, and you have no way to adapt an external, or you have to build your own if you want an external test fixture like this one or like this one. You can, of course, build your own on a little breadboard, but I find it a little bit annoying for the price that there is not a pin header like here. So let's go back to battery and auto power off. You already could see that the 3 ones that work with the push button, the Peak Atlas and the Fish 808040, they have auto power off. The AS4002 does not have auto power off. It has a hard power on switch. So if you forget to switch it out, what it does, it has a backlighted LCD just as well as the Fish, which is really nice. And the backlighting, that has a auto power off function, so it stops its backlight or switches the backlight off after, I don't know, 10 or 20 seconds. But the main circuit is only switched off with this hard power off switch. So I 2 or 3 times I forgot to switch it off, and came back the next day at the lab and the battery was empty. So a little bit annoying, but what I find more annoying is that the 2 Atlas types, they have no backlight LCD, and the LCD is not very readable. These 2 ones here are, concerning the readability, are extremely good, even if I look at an angle on the LCD. The Atlas types are not so good in this respect, so a little on the negative side for the 2 Atlas types. And what you can also see, this is a standard 16:2 LCD, just as well as this. Let's count the digits: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah, it's 16 characters and 2 lines. And these 2 have a graphical LCD, which of course can display more features, like the symbol of the device under test. So none of them, as you can already now see, is perfect. What I also find annoying is replacing the battery in these 2 is quite easy. Here it's external battery. Here you have a separate casing where the battery is inside, and you change it in a matter of seconds. The Peak ones, first of all, you have to unscrew them. As far as I know, there is a little slit here inside. Until now I never did change the battery. It might also be that you only have to use a coin in the slit and can open the case. Anyway, the expensive one, the more advanced one, the DCA75, it uses a single AAA alkaline battery, while the DCA55 has a totally, so obviously there must be a switch mode power supply to get the required voltages for the testing and for the microcontroller. This one here uses, as far as I remember, a non-standard 12-volt alkaline battery, a GP23A type, which is of course more expensive and more unusual. So if you're working in the field and your battery has run out of power, it's relatively rare that you have a replacement battery, because these GP23A batteries are not very standard and you won't get them at a gas station or at a drugstore. So also a little bit on the downside for this, the battery they use here. Why didn't they use of course the 9-volt battery is bigger, so it wouldn't have fit in the relatively small casing. Well, I prefer 9-volt battery because you always, you get them everywhere if you run out of power, and they are cheap and they are not that big. So that was it for a first look. I will provide an Excel file with all the properties of the 4 types, which you can download, and I give you the link also down in the comments. But now let's go over and start with testing and comparing them. First of all, with semiconductors. So let's start with the most simple of all semiconductors, with a simple diode. And there's one thing you should know, or you have to know, about the AS4002. It can measure diodes only when they are connected between the black and the red pin or test clip. The direction doesn't matter, but you cannot use the blue pin for the blue cable or the blue connection here for testing diodes. So that might be in the first look a little bit of a downside, but once you know this, you will, it's easy to remember. And during the preparation of this test, I also noted that perhaps this hard power on switch is not so bad for continuously testing, because all the other 3 types, they usually turn off when you do extensive testing, when you don't need it, and you have to press the test or power on button again. And there is also a difference between the 3 here with the outer power off and with the AS4002. The AS4002 continuously tries to identify a test component. As soon as I disconnect the diode, it displays no component, and if I reconnect it, it immediately displays the properties of the diode. All the other 3 types, they only start their testing cycles when you press the on or test button. So that's also for an ergonomical point of view, I think this one here with the continuously being powered on is in the end even better. And as soon as it detects a component, it also switches on the backlight. So if you're working in a dark environment, this is really quite handy, that it continuously tests or tries to identify components, and that it, as soon as it has detected a component, switches on its backlight. So this one is, from the usability in this point, better than, at least in my view, better than the 3 others. Now let's take a look at what they are displaying. So let's see what information we get from a simple diode from the 4 different testers. As you can see in the AS4002, we get two forward voltages at two different test currents, which is quite nice. So that way you can characterize a diode not only with a relatively high test current of around 10 milliamps, but also with a much lower test current of 0.4 milliamps. We get a reverse current in case the diode has some problem in reverse mode. That could be of interesting when testing germanium diodes, which have a relatively high reverse current. Sometimes also Schottky diodes can have a significant reverse current, especially when they are heated. So a standard 1N4148 usually has a reverse current only in the nanoamps or sometimes even picoamps range, and that cannot be detected by the AS4002. The AS4002 also makes quite a good use of the standard character LCD, because as you might know, you can program some graphical symbols of your own into the standard character LCDs. And here we get displayed where is the anode, where is the cathode, and also the symbol, because for beginners they don't always remember that the anode is the positive terminal of a diode, and the cathode, or here it is used a K instead of a C. That's probably due to the European or German spelling of the word cathode, which starts in German with a K. Not 100% consistent, but anyway, nobody will have a problem to recognize that the K is for cathode. And we also directly see, okay, the cathode is at the black cable and the anode is at the red cable. So from again, from an ergonomical point of view, the changing display every few seconds, you get one of the other measured values. You don't have to press any key. It automatically measures and displays. It continuously measures. So that's from an ergonomical point of view, I think this is quite good. It makes the best use of its character LCD. And now let's compare this with the Fish 8840. Again, we notice the longer test time, and that the device under test has to be plugged in or connected to the test pads or to the IC socket before the test starts. So that also is sometimes a bit irritating, that if you have not connected, have already pressed start, you have to press test again. Anyway, due to the large graphical LCD and the short auto power off time, which is a bit of an annoyance again, we get the symbol of the LED. We get at which test, at which points the anode and the cathode is connected. Anode and cathode are not shown as letters, but only you can only deduct it from the symbol of the component. We get a reverse current here of 8 nanoamps. I'm not sure if this is really the true measured, or here we have 6 nanoamps. So you see it's really on the limit of the measuring capabilities, the nanoamps range. We get the forward voltage, and we get the reverse capacitance, which is here 0 picofarads, because a 1N4148 diode has a reverse capacitance in the low picofarad range. So these values are really at the limit of the measuring capabilities. But anyway, it's a nice feature. Some other diodes can have a reverse capacitance in the tens of picofarads. What is missing is how large the test current is. So, as you might know, a diode does not have a constant forward voltage, but the forward voltage increases exponentially with the current through the diode. And so you can surely decide if it's a silicon diode or a lower forward voltage Schottky or germanium diode. You probably could differentiate a germanium from a Schottky diode by the different reverse current. So the low reverse current capability is quite nice. At least we perhaps can trust it from, I don't know, 20 nanoamps upwards. But what I find missing is the height of the test current. That's a very important value you have to know to interpret the forward voltage. So that's much better here with the AS4002, which tells you not only the test current, but which also measures at two different points, the test current and the forward voltage. Now let's take a look at the two similarly designed Peak Atlas testers. Again, we have to, the same as with the fish, we have to connect the diode under test before we start the test or on button. Then the first information we get only it's a diode or diode junction. Okay, but remember we have the same kind of LCD, 16 characters, 2 lines, and here we get much more information on the same type of display. Here we have to scroll through. Next is we get the information at which colored test lead the cathode and the anode is, but we do not get the symbol of the component. So again, for beginners who perhaps are sometimes interchanging anode and cathode, or don't know if the anode is at the left point of the arrow of the diode symbol or if it's on the right side, they could have made better use of the LCD, and only after the second pressing of the scroll button we get the forward voltage, and we have to press the scroll button once again to get the last information how high the test current is. So we have to press 3 times to get all the necessary information. Sometimes you simply don't have your hands free because you are fiddling around with your 2 hands to fasten the test clips at your device under test. So I don't know why they didn't put in kind of auto scroll mode, or is here a constantly changing display where you just have to wait until the value you are looking for appears. So ergonomically, I think this is not the best solution. Let's see if the more expensive DCA74 does any better. Again, the same procedure. At least now we get on the graphical LCD, we get the symbol, but again at the symbol A and K, anode or A and C, anode and cathode, are not displayed as a letter, so you know which component symbol you have under test, but you only get red is anode, green is cathode, and we get at least on one page displayed the forward voltage and the test current. So at least we don't have to scroll, but again the auto power off is, in my opinion, too fast. the readability of the graphic LCD is much worse. It's the worst of all four. You will probably not see it very good here on your screen because the camera is directly overhead vertically, but when you're working with this in the field, you are always looking at an angle onto the display, and it's really very badly readable, no backlight display. So again, some minus points in a case of, or in terms of usability or ergonomics. And let's see again if we get any more information when we press scroll. No, that's all the information we get. So to sum it up, for our first device under test, a simple silicon diode, ergonomically, I think this one is the best, directly followed by the fish, which at least has a clear, bright and big graphical LCD and which displays all the necessary information except for the test current and except for the letter A and K, or A and C for the anode and cathode. So these two are ergonomically the best, and these two are nearly equally bad in that term. The information itself is okay, but how it's displayed, how it's presented to you, is not very convenient. So next up is two anti-parallel connected diodes. For the AS4002, I've used a two-color LED, which has the same circuit, but instead of normal silicon diodes, there are LEDs. As you can see, the device apparently tries to test it, but it doesn't recognize it, because that must be also a firmware issue, because it has no problem with a single green or single red LED, but with a combination it cannot determine what type it is. And on the other three testers, I didn't use the two anti-parallel LEDs, but two anti-parallel 1N148 silicon diodes. Now let's see what the fish is doing. And we get, after some waiting time, we get a correct results. It measures on a anti-parallel connected diodes on pin 2 and two separate diode forward voltages, which as you can see are nearly exactly the same, only 1 millivolt difference, so that's quite nice, a good result. Let's see what our Atlas DCA55 is doing. Unknown faulty component. So it also has a problem. It cannot determine anti-parallel diodes. And the more expensive one, the DCA75, well, it now says it's a Zener diode because it measures a forward voltage in both directions, but it does not detect that it cannot be a Zener, but it must be two anti-parallel silicon diodes. Let's see if we can scroll through something. Okay, it measures as the reverse voltage and as the forward voltage, so the two voltages where the two diodes are connected, the same value, 0.700 and 0.701 at 5 milliamps. So it's also a software issue. It's halfway correct. You can deduct from the measured values that it must be two anti-parallel diodes, but the symbol is wrong, and that's quite so only the fish detects correctly what is put in. And I've also tried it before with the two-color LED, which is basically the same circuit, but with, of course, higher forward voltages. Now let's take a look and see what it displays. And we must get two different forward voltages, because the green, yeah, we get exactly the right thing. One of the LEDs has a forward voltage of 1.78, the other color has 1.96. So this one is the only one which displays a correct result. It doesn't matter that, for me, it doesn't matter that it doesn't say two LEDs instead of two diodes, because an LED is in the end a diode. But the correct circuit diagram, the correct different voltages, and it's not a Zener diode. So good point for the fish tester, 0 points for these two, and I would say half a point for the expensive Atlas. So next, let's see what we get with a network of two anti-parallel diodes, but this time they are not connected on their off-going side, but only on one side. So we have to use all three test pins. And as we know, the AS4002, there you have to put a diode on the black and on the red connection. So it displays diode network, but it only can determine halfway what it really is. So again, a minus point for the AS4002. Let's see what our fish is doing. And again, after some waiting time, absolutely correct result. 0.1 as the pin 1 is the common connection, and the two different forward voltages, the pinout is right. So very good result with the fish. Now the cheap Atlas in comparison. And it also detects a diode network. Let's see what we get from scrolling. Pinout for D1. Well, do we have to press one more time scroll just to get the pinout? Unbelievable. So how often do we have to press scroll to get the result? D1 forward voltage, test current, pinout for diode number 2. Again, scrolling, cathode, anode. Well, in the end, it has detected the correct pinout and the correct forward voltages, but I'm not very content with this shitty scrolling mode. Let's see if the more expensive Atlas DCA75 does any better. Well, at least due to the graphical display, we get a circuit symbol for the diode network, but we again have to scroll, and we get number 1 diode junction, red connection, anode, green is cathode. The forward voltage is of the first diode so and so at 5 milliamps, and we have to scroll and scroll. So again, although it displays the right values and the right connection, so nothing beats the fish due to its larger graphical displays. On only one page, you get all the necessary information, really in an understandable way, and I would give this 1 full point, this one, these two perhaps half a point, and the AS4002 gets 0 points. Now let's go on to another kind of diode network. So this time we're testing also two diodes which are connected at one common point, but this time from the common point, it's not as in the test before that they are anti-parallel, but now they are parallel and have separate cathode. I've switched off the AS4002 because we already know it cannot measure two diode networks. And let's again start with the fish, and I'm quite content that it will display the correct value just as in the test before. Yeah, and it does absolutely what it's supposed to do. And so also the two Atlas ones will give again a correct result, but only after scrolling through this menu, and not very ergonomic. So why doesn't it display on the graphical display near the symbol at which color is the common connection, which color is cathode 1 and which color is cathode 2? I don't understand this. Why do they have a graphical display? They don't make any good use of it. So again, 1 full point for the fish, half a point for the two Atlas, and 0 points for the AS4002. We could still use test also the other alternative, again with two paralleled diodes with only one common connection, but we know the result beforehand. It would be exactly the same, so we'll save some time. So next is testing LEDs, and now with the Pro Determinator AS4002 we even can see the continuous testing by the continuously flashing LED, and we have the same displayed values, the reverse current, which is here 0, and the forward voltage at two different test currents. Let's see what the fish 8840 is doing. What's also a bit annoying if you work for some time with that it takes some time after pressing the test button. Well, it displays the measured battery voltage, which is not very exact. And the Pro Determinator, the AS4002, is much quicker with getting a result. So we get again a reverse current of 8 nanoamps. I don't know if we can trust that really. We again get the and too fast auto power off. So let's wait again. What do we get? The testing takes quite some time. The AS4002 is extremely quick. Let's put it out, no component, and let's put it inside again, and you get nearly an instant correct result. So we get 8 nanoamps reverse current. Don't know if we can trust that. We get a forward voltage of 2.02 volts and a reverse capacity of 1 picofarad. It's so low we can't trust this 1 picofarad. Now let's take a look at the Atlas. And now you can see again, if you have either this zero force insertion socket or this, it's quicker to test a loose component when you have either a pin header or this zero force insertion socket. Here you always fiddle around, even if you have components that would fit inside a pin header or a socket, IC socket, and it takes just some time. And now again we only get, well, it has detected an LED or diode. We scroll, and now we get cathode and anode connection. Now we get the forward voltage, and now we get the test current. But again, 3 presses on the scroll button. I don't like that. Let's see if the more expensive one is doing any better because of its graphical LCD. Well, here we get at least on one screen the all the information at which colored test lead the cathode is, at which one is the anode. And we get the forward voltage. I don't know if 4 digits or digits is really if it's really that exact. I think 3 digits would have been enough. And the test current 5 milliamps. But again, as with a standard diode, only one test current. And so I think again the winners are these two and the others are, well, not as practical as these two. So let's change to a more difficult to test blue diode or a white LED. Just one thing you might have noticed, it detects that it is an LED due to the higher forward voltage compared to a silicon diode or a Schottky diode or a germanium diode. Quite nice that it predicts it must be an LED due to the higher forward voltage. But, well, you don't need this intelligence because you see that it's an LED. So anyway, let's go over to a blue or white LED, and the problem is not all analyzers will probably detect or this blue or white LEDs because their forward voltage is much higher, and let's see if they can manage that. So I don't have 4 identical blue or white LEDs here, so let's start with the AS4002 with a blue LED. And as you can see, although it is testing it, it doesn't recognize it. So apparently there is enough voltage to make it light up, but it doesn't recognize it as a diode or as an LED. So that's a little bit on the downside. Let's try if it does better with a white one, and also the same result. So apparently blue and white LEDs the AS4002 cannot test. Now let's make the same test with the fish. And again we have to wait. But at least after some times it says forward voltage 3.5 volt, and now we have really quite a large reverse capacitance of 80 picofarad. Let's see if we repeat the test, if it gets again to the same result. Yeah, nearly the same result. The reverse current seems to be consistently at 2 nanoamps, or in the range of 2 nanoamps. So apparently that's the lowest value it measures, and it's a kind of leakage current on the circuit and not in the diode. Because I don't think that an LED has a reverse current of 2 nanoamps at a test voltage of only 5 volts. So anyway, it has no problem with the higher forward voltage of white or blue LEDs, so it displays correct result. And now let's go over to the 2 Peak Atlas ones. Again, this takes just some times to connect the test leads. Let's see what it does. Again, we have to scroll and see, yeah, 3.29 volts forward voltage. So it has no problem with a white LED, and will have no problem with a blue LED. And let's see what the DCA75 from Peak Atlas displays. Also LED, 3.463 volts forward voltage at 5 milliamps. So all the three have no problem with blue or white LEDs, but here the AS4002 is on the downside. That's a negative point. You're lost when you want to test blue or white LEDs, although the test voltage, which is 5 volt, would be enough, and we can see it again if we plug in the blue LED. Apparently, because it lights up, so it must be a firmware issue. It should be able to measure it because it thinks, well, there is no diode with forward voltages of 3 volts, so it must be a either no component, which is of course wrong. Well, I'm not content with this result. It could do better, and perhaps it's only a software issue that could be solved with a firmware upgrade. But to be honest, I don't think that the developer is still active with this. with this thing. As far as I know, the firmware hasn't changed over the last 5 or 10 years. That should be remembered. The AS4002 has problems with blue and white LEDs. So to finish our test of diode networks, we will in short test again the same kind of networks, but this time with LEDs, with bicolor LEDs, which can come in some variations. We've already seen the simplest of all, the two-terminal bicolor LEDs, where you have two LEDs anti-parallel welded together. And let's see again what the different testers. We already know the AS4002 cannot measure diode networks, even not two-terminal networks, so we've switched it off. As we already expected, the FISH 8840 correctly identifies how the two antiparallel diodes are connected to the test socket. It displays the two different forward voltages. Does not display us that it are LEDs. You have to deduct that from your own, from the high forward voltages. In theory, you even could deduct which kind of color the LEDs is, but this is not, because we don't know the test current, this is not very exact, but well, LEDs have the advantage you can see which color they are. And relatively okay, the result, especially the graphical representation is always good with the FISH tester. Now, the Atlas DCA55, it correctly identifies that it's a two-terminal bicolor LEDs. It can deduct this from the relatively high forward voltages. But again, we have to scroll for many push button presses to get the detailed results. Why is this pinout for D1? Why? It's absolutely unnecessary to display this text, because it would be sufficient to have this one. And we get the forward voltage and test current for diode number 1. And again, unnecessary pinout for diode number 2 and forward voltage and current. So again, ergonomically, absolutely on the bad side. I really don't like it. It doesn't make fun to work with this one. Let's see if the more expensive one is any better. It even shows yes, it is a little bit better. It shows a correct the symbol of the two antiparallel LEDs. It shows a little bit more information on the first screen, but when we are scrolling, it scrolls only one line upward instead of after the first press of the scroll button. It should display all necessary information of LED number 2 and to get number 1, and to get to number 2 we have to scroll 2 more lines upward, totally unnecessary. So again, it doesn't make a good use of its graphical LCD. Ergonomically, it's really a catastrophe in my case. It could all be solved by a firmware update, but I don't know if this is if these two can be manually updated with firmware. This one, as I already told you, has a USB connection, but I don't know if it's firmware updatable over USB. So I don't know what the people at Peak Atlas thought about this. Apparently they don't know of the other models which do it much better. No matter if it's a 2-line by 16 characters character LCD or if it's a graphical LCD, they could have done a better job. So, and finally, there are also so-called 3-terminal LEDs. We have simulated here one and soldered 2 together. They come in 3 different variations. You could have a common anode and separate cathodes, just as in our diode networks. You could have the reverse, a common cathode and separate anodes. And in theory, there could also be one with one cathode connected to the anode of the second one and then the other terminal free. Now we won't test all three because the results will be basically the same. We just concentrate on one, the 3-terminal LED with common anode. Let's see what the fish tells us. Again, we can already predict what it is displaying. The correct pinout. It takes a little bit longer in this case. Okay, it shows the correct pinout. Terminal 2 is the common anode, and terminal 1 and 3, two apparently different LEDs because of the different forward voltages. So all is okay. Again, missing is the test current, and it does not say it's an LED. You have to deduct it from your own. Now let's see if the cheaper Atlas one can display. Yes, it correctly identifies 3-terminal bicolor LEDs, but oh sorry, again the test button. Now let's scroll, and again you have to write down the connection of diode 1 and diode 2 to see if which kind of 3-terminal LED of the 3 variation it is. So ergonomically, again, not very good. So we'll stop here and see if the DCA75 does any better. Well, that's at least a bit better. It shows the correct component symbol with the common anode connection. It says bicolor LED with 3 leads. Okay. Common anode. Okay. But again, we have to scroll. LED number 1 has the red test lead on the anode and the green one on the cathode, and we have to scroll and scroll and scroll to get all the information. So a bit better than this one, but you already know my opinion about the ergonomics of these two. They could have done a better job. So now let's finish testing 2-terminal and 3-terminal LEDs. Because the results are quite similar to diode networks of standard diodes. And let's go over to our next device under test. So, as you all know, a bridge rectifier has 4 connections, so none of the test devices will be able to fully test a bridge rectifier. Usually you have to do it by testing each diode in the bridge separately, which we could do with the AS4002 by simply turning it 90 degrees around and test each diode of its own, and if all 4 are correct, which is relatively quickly done here. So all 4 are correct. We know that the bridge rectifier is fully working. There's no shorted out diode, but we have to make 4 separate tests. Now let's see if we connect at least 3 of the connections to one of the other 3 test devices, if one of them or all will display us something useful. Okay. We get what we expected, because if we only test 3 pins of a bridge rectifier, we only can measure 2 diodes separately with 3 pins. So the result basically is correct, but we still had to rotate it at least 2 more times to be absolutely sure that the bridge rectifier is all okay. Let's see what the 2 atlases are doing. They should display a series diode network. Pinout for diode 1, so it also detects 2 diodes, which is basically correct. So we get the same result as with a 2 diode network, and would have to test at least 2 other positions to be absolutely sure that the bridge rectifier is okay. So there's, I would say, not a big difference between now the 4, because here we can put the 2 pins of each, so each single diode with 2 pins relatively quickly. The AS4002 is not so much on the downside as in the tests before, where it couldn't detect 2 diode networks. So we are quickly ready. Let's take the fish as the second best one. We always have to wait for the starting screen and until the battery voltage measurement is ready, and then we get 2 diodes measured. But then if we rotate it, we again have to press the test button and again have to wait. So the AS4002 even is now quicker, because we don't have this waiting time as in the other 3 models. So I would give half a point to each one of them for testing bridge rectifiers. And now finally, as final diode tests, we still have Zener diodes. Let's see what the 4 different models are doing with that. So I've put a 2.7 volt Zener diode inside or at the connections of all of the 4 test devices. And again, on the downside, the AS4002 doesn't detect it, although the measurement voltage should be large enough that it could detect. So it's also a kind of firmware thing. It should be able to detect that on one, if it connects the plus side on the anode, that it's a normal diode, and if it connects the plus test voltage on the cathode, then it should measure 2.7 volts. So it could deduct from the measurement result that it must be a Zener diode, but it doesn't, even with when the voltage is low enough concerning the Zener diode, that it should be able to detect. Let's see what our fish does after waiting some seconds. Well, it doesn't say that it's a Zener diode, but from the different forward voltages, so the connection diagram is correct. It detects 2 anti-parallel diodes, which have a common connection on pin 3 and on pin 1. And in the one direction, it measures a forward voltage of 2.59 volts. On the other side, the typical silicon forward voltage of 0.7 something volts. So you can deduct also from that it must be a Zener diode, because connected one way, and you could also compare this with the black ring on the glass body of the diode. You could deduct, okay, on the one direction, which is here displayed with 841 millivolts, that must be the forward connection of the Zener diode. And let's wait again. And the higher so-called forward voltage, which is in reality the reverse voltage of the Zener diode, you can deduct that it must be a Zener diode. Now we can also already predict what the peak atlas will detect. They should say, well, LED or diode junctions. Okay. Anode and cathode, forward voltage. No, the cheap one only says it's a diode, because apparently the test voltage is not high enough. So that's a little bit disappointing for the cheap one. Let's see. We had a similar example with the anti-parallel bicolor LED, where the more expensive one already told us Zener diode. Now it's correct. So depending on this time, the atlas is correct with the Zener diode, but if we would reconnect the bicolor LED, it would also display, I will take it out again to see it. Let's first of all scroll down. The reverse voltage 2.7 something volts at 5 milliamps. And again, it has too quickly turned auto power off. Let's see if we get something more in the scroll mode. Yes, the forward voltage in the forward connection is 0.748 volts. Do we get something more? No, I think that was all the information. Now, to show you the comparison, let's put again the bicolor LED with two anti-parallel LEDs, and now it will, as you remember, also tell us, no, this time it detects a bicolor LED. Interesting. So it depends a little bit on the measurement situation. Quite interesting. Now, as far as I remember, the first time it said Zener diode. Interesting. So anyway, it's correct. So this gives 1 point. This gives, well, 3/4 of a point because it's the correct result, but you have to deduct from the displayed values. It must be a Zener diode, and the cheap Peak Atlas and the AS4002 cannot detect the Zener diode. So quite interesting and very different results. And now let's go over to a Zener diode with a higher voltage. Let's suppose we go up to 5.6 volts and see if they are still able to detect that. Alright, now I've put in in each of the three testers which should be capable of measuring Zener diodes, I've put in a 5.6 volt Zener diode. My prediction is the fish will not be able to test it because it regulates down from the 9 volts to 5 volts. So the Zener voltage is higher than the test voltage. I predict the same with the DCA55, and from the datasheet the DCA75 should be able to measure also a 5.6 volt Zener diode. So let's see. The fish will display us only a diode, right? Not a Zener diode or two anti-parallel diodes as we saw before with the 2.7 volt, but only the forward biased connection with a reverse current of 1.1 microamps, which might even be true now because Zener diodes have also, with lower voltages, have much higher reverse current, even if they're not in their if the voltage is not in the range near the Zener voltage. They start to conduct even at much lower reverse voltages, so this might be even correct. The forward voltage when forward biased is 890 millivolts, that might be correct, and a relatively high reverse capacitance, which also might be near the true value. Now, let's see what the cheap Atlas is doing. It detects a diode just as the fish, but when we scroll down, will we only see one forward voltage? Nothing more. So it also thinks it's a simple diode because the test voltage is not above, is probably also only 5 volts. So it cannot get the Zener diode into conductive mode with reverse polarity because simply the test voltage is not high enough. And what does the more expensive DCA75 say? Well, it does as expected from the datasheet. It detects a Zener diode with a reverse breakdown voltage of 5.566 volts and a forward voltage of 0.797 volts. So here only the expensive DCA75 gives us a good result, and as a final test, let's plug in that one a Zener diode with 27 volts in, and from the data sheet it shouldn't be able to measure this, but let's see. Press test again, it's testing, and it only detects the forward diode inside the Zener diode when it's forward biased, but it does not detect the reverse breakdown voltage. So to make a summary concerning Zener diodes, for low voltage Zener diodes, the fish is okay. The cheap Atlas DCA55 is, well, moderately okay. And at least up to, I think it's 12 volts is the limit how large the breakdown voltage can be measured. It's, well, it's okay. I would give it half or 3/4 of a point. 1 point it would only get if it could measure up to 30 or up to 50 volts breakdown voltage, which it can't. So that was first part of the test with all kind of diodes, diode networks, and Zener diodes. And now let's go over to the more interesting 3-pin semiconductors, also called transistors.